Hello from West Yorkshire, England, UK. My name is James Parker. I'm the XRF and XRD Sales and Application Specialist for Olympus UK, and today I want to show you how to efficiently and accurately separate superalloys for recycling using the Olympus Vanta XRF analyzer. Many alloys used in aerospace, oil and gas, automotive, power generation applications need to be resistant to extreme temperatures and sometimes extremely corrosive environments. As such, these superalloys have grade specifications that include explicit elements that give the alloy the required properties. These specifications often have overlaps with each other. When collecting scrap materials from manufacturers for recycling, these alloys should be separated not only by grade, but also by the explicit elements contained within them. The cost of supplying recycled material to the foundries or melt shops with incorrect element concentrations can be colossal. These elements can adversely affect whether the melt is viable for its next application and is critical, especially with the growing demand for furnace-ready chargers. The Olympus Vanta's highly precise and accurate results can also ensure correct melt chemistry and/or any requirements for blending. This means that the chemical analysis of these exotic elements is critical to correctly determining the alloy grade. Here I have a few typical samples of superalloy components being sorted at a recycler. We have a couple of engine turbine blades and some small offcuts of different alloys. So let's take a couple of measurements. So we line the analyzer up, getting as flat as we can, move all our hands away and then shoot the sample. So that material's MAR M246, maragin. And you can see very quickly, within 2 or 3 seconds, we get a good grade match, GTD 111 for this sample, and the chemistry is displayed below. Note these samples are not particularly clean, they're not flat, and this can sometimes change the result. However, we did get grade matches for those two samples of GTD 111 and maragin M246. When we look at the chemistry, you can quickly see which elements are outside of the grade specification, either by a red circle, unfortunately we didn't get any on this test, or by looking at the black arrows indicating where the actual chemistry measured fell within the grade specification. We can also reorder the elements on the display simply by pressing the column headers. So if we wanted the lowest element concentration at the top, we can have that. You can also customize them to have important elements shown, and the easiest way to do this is if you go into the main menu, scroll down to element order, and then you can click and move specific elements to wherever you choose. And then from the main screen again, click on the column header for elements. The Vanta comes pre-programmed with over 2,500 alloy grade specifications. As these grade specifications can have many variations and are being modified regularly by manufacturers, the Vanta software user interface allows you to add new grades, fully customise and modify existing grade specifications directly on board. This means you can always be sure the grade matches you get are correct. I'm using a custom grade library I created with a customer where the tolerances for each element have been edited to allow for faster grade separation. So if we go into the main menu, into grade match settings, we can scroll down to libraries. This is my superalloys library. We can highlight it, click on the edit button. We can see all the grade specifications listed, and we can also search for specific grades. And then by clicking the pencil icon, we can edit that grade specification directly on the analyzer and change the minimum and maximums. So let's test these other samples and see whether we can get grade matches for these or whether the surface prep needs some work. Now this smallest one causes us some problems due to alignment, but as long as you get the sample central and hold the instrument still, we should still get a good result, and as you can see on screen, CMSX4. This sample, the edge of the turbine blade is quite difficult to measure, but as you can see, in less than 5 seconds we get the grade match. And sometimes you need to test with a slightly different orientation just to ensure you can get a result. Sample preparation is critical to ensure the best analysis possible. By grinding or cleaning the surface, you will vastly improve the analytical performance on the elements with lower concentrations, especially the commonly exotic elements that have the overlaps determining the alloy grade. These are such as tungsten, tantalum, rhenium, zirconium. As you can see on this turbine blade, the sample has been ground down at one point, so if we test an area that's not been sample prepped first, you'll notice the chemistry doesn't give us a grade match and that the platinum level is really high, and that's because this blade is platinum coated. If we test the area that's been ground off, however, you will see that we get a grade match that is an exact match for Rennie 142. And we can quickly swipe back and forward within the software to check the last result and the most recent result. So once we have the appropriate testing time and sample prep, we can accurately separate and quantify the critical elements as part of the sorting process. Most customers will still get at least one lab assay carried out in a batch. However, they then pretty much rely on the Vanta results for their chemical analysis needs going forward. Due to Olympus's patented XRF technology, we can detect and quantify these lower concentration elements much faster and with more precision than other handheld XRF analyzers. This makes the Vanta C series the perfect tool for analysing these types of alloys. Thank you.